All right, hello everyone. My name is Caleb Hale. I am the Director of Communications for the SIU Alumni Association. It's been a while since we've done one of these, but we are getting back into the practice of doing some live chats with people around the university for alumni to get to know a little bit more about their research and other programs on campus today as well. We'll start doing these every couple of weeks now, and you can expect to see them either on our Facebook page or our YouTube channel. One note I did want to put out to everyone, if you can see down in the corner of our screen here, we did launch with a new smartphone app for the Alumni Association earlier this week. At any point, if you want to, you can just point your phone's camera at that little QR code there, and you're able to download that app. We're having everyone give it a try. It's a place for news, information, updates about what's going on at the university and within the association. It's a good way to stay connected. So at any point, if you want to point to that app or point to that QR code and download the app, give it a try, give us your feedback on it, and let us know what you think. So I am here today with Keith Gagnon. He is an associate professor of chemistry and biochemistry at SIU, and he was leading a team late last year, I guess, and earlier this year, that has that pinpointed a new variant of the COVID-19 virus. And it's something you probably heard an announcement about in the news a couple of weeks ago, but we wanted to bring him on and let him talk about what he has been doing recently. So Keith, I'm going to throw it to you at the moment and just let you kind of introduce yourself and what your research has been about.
Sure. Thanks, Caleb. So I've been at SIU for several years now. I'm an associate professor. I have two appointments. I'm in the School of Medicine in the biochemistry and molecular biology department, and also in the chemistry department, chemistry and biochemistry. And my lab has mostly focused on some neurological diseases, particular one called Lou Gehrig's disease, or ALS. And the other is an area where we're interested in gene therapy applications. So we're doing some enzyme engineering to make this enzyme called CRISPR a little bit better, a little bit more amenable as a medicine for human use. And then, of course, during the pandemic, when everything sort of struck in March and April, we asked if there was something we could do. And we realized that sequencing the actual genome of the virus, so all of its, the letters that make up, its genetic material, would be useful, because over time, the virus is going to mutate and change. And that would allow us to track the virus and its changes, and would also allow us to reconstruct some of the pandemic a little bit, how the virus is moving from one place to the next. This approach is often called genomic epidemiology. It has a lot of uses. And so we started working on that. We started getting the ball rolling in actually late spring. And by the end of the summer, we got a lot of the approvals in place and started doing some of the work. We didn't really pick up our sequencing efforts until late fall, early winter. So November, December really picked up. And it was at the end of December when we were sequencing a lot of genomes. And like a lot of other groups, we were sort of hunting for the UK variant, which was really taking over in the United Kingdom. The variant's often called the B117, or the variant that first emerged in the UK. And so we're looking for that variant and variants like it, and we kept seeing a large branch on what we call a phylogenetic tree. And these are just visual ways to compare all the different virus variants and see how related they are, and see what kind of mutations or changes they've acquired. And so we saw this sort of new branch off the tree that was really filling out pretty quickly, and that's the one that we investigated. And we called it 20C-US because it branched off of another branch called 20C. And it appears to be, a US, sort of born and raised in the US in simple terms. And that's the one we characterized and we're trying to follow right now. And we're seeing what new mutations it's acquiring and trying to figure out how it sort of rose to dominance in the US. Because right now, about 1 in every 2 cases of COVID-19 in the US is this variant of the SARS-CoV-2 virus. So that's kind of where things are at the moment and what we've been doing over the past couple months.
Okay, and you found this, I think you pinpointed it started somewhere in Texas?
That's correct. So, I mean, we originally were looking at our data was Illinois specific data. And it turns out that the variant, this 20 CUS variant, is very prevalent in the upper Midwest. And so it really jumped out in our data set. It's not so prevalent in some other states like California, for example. So I think it made it easier for us to find it that way. And then when we looked at the national level data and traced back as far as we could in the databases, the earliest virus genome that we could find that had the signature mutations of this variant was from the Houston, Texas area on May 20th.
Okay. What was it that kind of stood out about this variant here that kind of started making it easy to pinpoint or spot within the crowd?
Well, I think initially it was missed or not considered important because it didn't have some of those mutations that are the calling cards for the B117, which is the variant that was found first in the UK, and then now some other variants that were first seen in South Africa and Brazil. So it kind of flew under the radar a little bit, but what really jumped out at us was its abundance. It was just, there's so much of it. You know, by the time we started looking at it, it was about 40% of the genomes in the database from the US were this variant, and no one had ever discussed it. No one had ever talked about it. No one had ever looked at any of the mutations it had. And so that's why we decided to follow it. It has 5 sort of unique mutations that really give it its calling card. These mutations do occur in some other places in other variants of the virus, but they all come together and it makes a unique combination for this particular 20 CUS variant. And so that's sort of what we began to look at closely, is those particular mutations. And with respect to those mutations, there's 1 or 2 that look interesting. One in particular is in a gene that helps control the mutation rate of the virus. Of course, it's yet to be determined if that actually does have an effect or not, but interesting sort of lead to follow there.
What kind of impacts were you kind of looking for once you kind of pinpointed this strain? What are the things that you kind of start looking for? Okay, we found that this is in the mix in the population. Are there any? I guess it's just what kinds of things do you look for from there? What's the next step?
Yeah. So, well, again, we saw it was highly abundant. So we wanted to find out, well, how far back can we trace it? We did that. What states is it most prevalent in, or can we look at how it sort of spread? It looks like it sort of really spread starting in the central part of the U.S. and then outwards to coastal areas. You know, the obvious questions are, is it more transmissible? Is it more virulent or more dangerous? Does it result in higher mortalities or simply more cases? Those are just questions we don't have answers to. They're just pretty difficult to really to nail down. There's no gold standard tools that we can use or that are really available to us with our current data set that we have. But we are doing some analyses to try and figure that out. But at present, what we see is the rise of this variant to dominance in the US coincided with a little bit the second wave and certainly this third sort of fall wave of the pandemic, where we had just a massive number of cases. But what you don't see is the mortality rate or the number of deaths per case going up. You don't see the number of hospitalizations per case going up. So you don't have any trends that suggest it's more dangerous. And the question now is, how did this variant become so dominant? Did it just get lucky, or does it have some special features about it that we need to look very closely at?
And that's kind of where you're at right now, just to see what is it that makes this the choice variant that's in circulation.
The alpha variant in the US. I mean, the early preliminary data so far is suggesting it can't be just explained away by chance, not entirely. And we are trying to collaborate with a group to actually test some of these variants of the virus in human cells and called cell culture to see if there's any special properties that are intrinsic to the virus itself that could make it maybe grow better or there's different parts of the virus life cycle. We often talk about how it gets into cells or how it evades the antibodies in the immune system, but there's so many other parts to the life cycle that could contribute to it just being a better virus maybe. So yeah, that's what we're looking at.
And these are properties that kind of make it the most transmissible from what you've seen thus far. Are there any properties that make it more virulent or more resistant to current vaccines that are out there?
So the original sort of founding or parental lineage or sort of the initial form of this variant doesn't have any mutations that we would be really worried about at first glance in terms of vaccination or transmissibility. But there's multiple genes mutated and there's a lot of moving parts. Even though it's a virus, it's still pretty complex. But from this, looking on the surface, sort of, so to speak, or superficially, it doesn't look like there's anything to be too worried about. And so part of its rise to prevalence didn't require any of those mutations that we typically see as hallmarks for increased transmissibility. No evidence for increased virulence at this point. What we are watching and following is the evolution, or I guess the adaptation of the virus or this variant to its host or its environment. And so as we're doing that over the past month or so, we're seeing it start to accumulate new mutations that could be of concern. And this is not a surprise. We're seeing this all over the world, and we're going to see more of this. It appears that the virus is sort of converging on mutations that help it transmit better or survive better or evade the immune system better. So it's yet to be determined. I mean, we have to sort of wait and see, but the types of mutations that the virus is picking up seem to be converging on a solution that helps it reinfect folks and possibly partially evade vaccines. Not necessarily more virulent or more dangerous, although those things can go hand in hand, I suppose. It's hard to tell. Just getting higher transmissibility could lead to more deaths, obviously, but you could look at that as death rates. So yeah, we're going to watch this and keep an eye on it. I think we have to be very wary of what's already in the US and how that's changing over time. And currently, we're pretty preoccupied and fixated on these international variants, as we should be. However, we don't want to miss what's sort of in our own backyard and make sure that that doesn't sneak up on us, if that makes sense.
Yeah, and that was kind of what my next question was. We've heard a lot about the UK variants and some in South Africa as well, but you don't. While I think we, locally, definitely being at SIU, we heard about it, but you haven't necessarily heard about this on that one. Is there any particular reason why this hasn't kind of matriculated up to the top of the public psyche right now, or is it just lack of coverage, or is the research still so in flux right now that there's probably so much research and new data coming in every day on this?
No, exactly right. We monitor it pretty closely. Different research groups and the CDC, they have different focus for what they want to put their energy to. And I think the CDC really is their main effort is to track and monitor the international variants which are being introduced into the US. And that's exactly what they should be. That's what we expect them to do. They're, our national government agency. As an academic, though, my lab has a little bit of a luxury to focus on a couple other things if we want. And so, again, we've decided to look closely at this 20C US variant and follow it. So what would propel our variant, so to speak, but this US variant that we found to the mainstream would be if it acquired mutations that were similar to those that we see in the ones that first emerged in the UK, Brazil, or South Africa. And actually, that's exactly what we're starting to see. But we have to wait and watch because we need to see if any of these take hold and begin to expand, or if they're just, because mutations can pop up here and there and then sort of go away. You have to get a variant that comes up and then gets passed on to a sufficient number of people to then really transmit and take hold. If that makes sense. So we're watching that. I mean, I think the players and the parts are already in place, and we're poised to see a significant change in this U.S. variant and a couple other U.S. variants. I'll give you an example. There was a variant from the Santa Clara County in California that was detected several weeks ago. Actually, it was only a few weeks back, and it has pretty quickly taken over large parts of California, or I should say, it makes up a large proportion now of the genomes that we're sequencing from that part of the country. And it has this one particular mutation. And I should be clear that the mutations that I'm talking about and that we're most fixated on are in this gene called the spike gene, or the spike protein. So you'll hear that again and again. And so when we see mutations in the spike protein, and in particular parts of the spike protein, that's when we sort of raise the red flag. And so we're starting to see those in a lot of these actual US variants. These are variants that were, like I said, they emerged in the US, they're born and raised in the US, they didn't get imported from somewhere else. We know this because we can track over time where they came from, and we can follow where they're going. And so, I mean, that's what we should expect, and that's what we're seeing. And so I think in the coming weeks, we may find that there's a US variant that emerges that has some of the properties of these international variants, and then the spotlight will shift to that a little bit. The thing I want to add though is that I think we should be careful trying to pit one variant against another. You know, is the UK variant going to take over by March? Is the South African variant going to do this? What we're seeing is many different mutations and variants sort of emerging, and like I said, they're all sort of converging on similar mutation profiles that and I think part of this is driven by the fact that the population is starting to be enough people have been infected. We're not, of course, near herd immunity, but just getting enough people that have been infected or have taken the vaccine makes it harder for the virus to transmit effectively. And so any mutations that help it transmit better should get retained or selected for, if that makes sense. This is up until a few months ago, there was so much of the population that was naive and uninfected that there was not a lot of pressure for the virus to change and adapt. And so I think we're starting to see some of those pressures come into play now. And so we should expect more variants that have a lot of these similar mutations in the spike gene and going forward.
Yeah, I think it's clear that probably what people don't necessarily think about is we're not fighting this static organism. It's fighting for its survival just the same as we are as well, and it adapts to that as well, much quicker than we're able to necessarily on that. So I think probably a lot of people have resigned themselves to the fact that COVID-19 has got some staying power with it, and it's probably going to be in circulation for quite some time now, if it's not just one of these annual cycle things that kind of come up that we kind of like the flu virus. But what's kind of we've been living under the shadow of this for probably better part of a year now. People are getting fatigued. The fear of this thing is not what it was last year. Fear can't last forever. I think fatigue sets in. People are getting misconceptions about where we are in the timeline of this thing. Mm-hmm. So what kinds of things, knowing what you know and studying particularly how these things move through communities and the general public, what kinds of advice do you give people in terms of what should they know? Not that they should be afraid, but they should be aware of what's still happening and how this is still moving through the virus, even though they're not necessarily as petrified of it as they were, say, last April.
Yeah, I think the good thing is we've all gotten pretty comfortable wearing masks, for better or worse. And I just, simple advice, just keep wearing them when you're in public. I don't think it's so much that we have a problem with wearing masks. We just want to be able to go and do things more that we couldn't do before. The vaccines are going to help us get there. And I think there's been a lot of predictions in the media and by some of the experts. And I have to agree in general that the vaccines are significantly reducing severe disease and also reducing or eliminating death in many cases. So it's taking COVID-19 from a severe disease to something that's a little more mild. Instead of, hey, I may die from this, hey, I'm going to get a nasty cold, but I'll be okay. So hopefully that's the direction we continue to move towards and hopefully by the summer months, we'll be in a much safer place. Where it's a little bit of a foot race with the virus, trying to make sure we vaccinate as many people as we can before the virus can take on more mutations. But just slowing the number of cases that are spreading slows the opportunities for the virus to mutate. I don't think this virus is going to mutate to the point where it's going to completely evade all the vaccines we've made in the near future. So we're going to continue to have some tools against it. Also, infections, the more people that get infected, eventually we reach a near herd immunity situation. And the last thing I'll say is the virus is taking its sort of natural course. It's trying to adapt to its environment and its pressures. A virus ideally should evolve so that it's low lethality for the host. It's not super dangerous for the host, but transmits very well. And so, I guess maybe that means if it sticks around, it's moving towards a seasonal sort of flu-like virus. But hopefully that also means that if it sticks around, it won't be as dangerous and it'll become a little less lethal. So I don't think the future is really super grim. I do think the vaccines have made a world of difference. If you can get vaccinated, I would say please do it. These vaccines are as safe or safer than any other vaccines, from what I gather. And they will protect you, and they'll just basically help everybody from a population standpoint. So yeah, again, not super grim. I think the future's looking good, but we do need to just hang in there, keep a close eye on things. It will get better in the coming months, hopefully. So
Yeah, I think everyone we've been working on timelines ever since the beginning of this, all the way from the fact when we thought this would be a couple of weeks until you get to the point of, okay, we'll get to a vaccine, and now it sort of feels like late summer is kind of another milestone point, another checkpoint of whether that kind of determines how good or bad off we are with this thing. Is that a realistic checkpoint, even with all the variations that are moving through?
I believe so. I believe the vaccines are really the game changer here because they either eliminate the disease for a lot of people, or the disease is less severe, and then what we should see is death rates should plummet as more people get vaccinated. I think it's very reasonable. I think the summertime we should definitely be looking up by that time. It may get a little worse before it gets better in terms of the variants, because there are going to be variants like, for example, the variant that was first seen in South Africa appears to be able to sort of get around some of the vaccines a little bit. Not completely, except for possibly one, but most of them are very effective. So we'll have to keep an eye out for that. However, I will say that some of the technologies that are used to develop the current vaccines, like the Pfizer and the Moderna vaccine, which are the RNA-based vaccines, those are sort of platform technologies, if you will, so they can very readily be adjusted and adapted. And I know that Moderna and Pfizer have already made potential booster shots, if you will, where they'll be able to work even better against these new variants. So I think things are looking up. We will get ahead of this. Just hang in there for the next few months. Just keep doing what we're doing. There's no special new advice, but there's not a lot to be fearful for. I think things will get better. Just hang in there.
Right. I think this is, I think the fear has naturally subsided over this, but you can't necessarily get to the point. You can't necessarily get to the point of carelessness either, which is where it's natural to go to, because
we know.
There's only so much hand washing you can do.
We know so much more about the virus now too. We understand so much more. We know it's primarily passed through the air. Wearing a mask is very, very effective. And my laboratory has been able to operate mostly uninterrupted through the whole entire pandemic. A lot of our research obviously is essential research, right? But the key thing that we found that is the most valuable is just wearing an N95 mask. Even a homemade mask dramatically reduces your chances of passing it on, but mask wearing is super effective for this particular disease. So so we've learned a lot about it since it started.
Right. And there's some new CDC study out today that says 2 masks might be better than 1, but
yeah.
Well, let's just say we'll all be satisfied with 1. If we can get everyone just out with 1, I think they'll be okay with that. Keith, what else? What are kind of your next steps on either on this research or following along with anything else, what are kind of your next steps from here? What are you going to be looking for and doing from here?
So, we're going to continue to sequence virus genomes. We're starting to get really good at that, I think, and very efficient. There's a big push for everybody in the U.S. as a whole, to do this better. My lab has been making a pretty big impact in the Illinois area, and so we just want to keep helping there. From a sort of biology standpoint, we're going to continue to follow this virus and watch it change over time. And I feel like a role that my lab can play is a little bit like the U.S. watchdogs. There's a huge preoccupation on the international variants. Those do need to be watched, but not everybody has to watch them. And since my lab identified and characterized this U.S. variant, we feel it makes sense to follow this variant and watch how it changes over time. And if we see anything important, we will alert the CDC and the public health departments and let them know, and share that with everybody, of course. And so I think that's what we're going to be watching out for. And what I'm interested in is sort of this new dynamic that we're entering into for the virus itself. I don't think we're going to have any one variant that dominates everything. And I'm going to say something a little provocative here, is I think the CDC is a little bit wrong. I don't think the UK variant's going to rise to dominance and take everything over in the US. And there's a couple reasons why. I have several reasons why I believe that to be the case, and time will tell. But I mean, it doesn't mean that there's not going to be other variants of similar or even worse concern. That's actually the whole point. There's multiple variants now converging and all sort of coming up with similar solutions to get around the immune system, for example. So the UK variant will be important. But we're going to see some in the U.S. come up and play a role. We're going to see other international variants. The U.S. is a very different landscape than other parts of the world. I mean, we have states, but there's no restrictions on interstate travel in the U.S. And we don't have a centralized, specific way to deal with things yet, still. And even just detecting some of these variants, it's really difficult. We do a really low level of subsampling, right? We're only sequencing less than 1% of all the cases out there. So if we find a couple examples of a variant that has got some mutations that are concerning, we can be sure that we could probably multiply that by at least a factor of 10 to give us an idea of how much is actually really out there. And so, time will tell. It's going to be a complex environment for the variants going forward, but I do again believe that the vaccine efforts are going to suppress a lot of this and help us get a hold of it. And this will continue for years to come. We will continue to monitor and watch the evolution and hopefully the die-off of some of these SARS-CoV-2 variants, but time will tell.
And do you think, is there still enough put behind in COVID testing as well? I know a lot of the conversation has shifted to vaccination, but it would seem that testing is critical to tracking the variants in this. That's where you track from.
The testing, absolutely. The testing need has not changed. We still have people, still have to do a really good job with testing. What I'll add is that one of the tests that's commonly done can pick up the variant that was first seen in the UK, the B117. And so that's how we're able to track it so well in the US now, is we have a specific test we can do that doesn't even require us to sequence it, that gives us a hint that it may be there. And of course, then we sequence those particular subset of cases to make sure. But in the coming weeks, there will be new tests that are put out that will help us specifically detect individual variants and track them better. So that's going to get better also.
Anything else you want to add before we sign off for the afternoon?
Well, I just want to thank you for this opportunity to share what's going on in my lab. And if people have questions, they can look me up. Feel free to send me an email, personal email, if you need to. I'll try to get to it as soon as I can. And happy to talk more about what we're doing in our lab and here at SIU.
Yeah, we always like to give specifically alumni the kind of the insight and the deep dives as to some of the stuff that is actually going on here. Not only the fact that it gives us some bragging rights on stuff that we're contributing, and I SIU has contributed quite a bit to at least the
Yeah.
local COVID effort.
Oh yeah, we were aliquoting, which is making the samples for the viral transport media early on, and the sequencing is an effort I sort of spearheaded, and but we've been doing a lot, and I think it says a lot for the work ethic here at SIU. We can make big important contributions, not just locally but at a national and global level with just by picking important areas to study and focus on. And so I think we've got a good track record there.
All right. Well, Keith, thank you very much. You enjoy the rest of your day. If you can stay inside, keep warm. I know a lot of people are home today, not just because of the virus, but because of the weather. So everyone stay.
Nice snowy frozen rain coming down behind me.
Yeah, watch your step when you hit the sidewalk. So.
Exactly.
All right. Well, everyone, thank you very much for your time today, and we will be seeing you back here in a couple weeks for another broadcast. But Keith, thank you for sharing some of your time and knowledge with us today.
Yep. Thank you. My pleasure.
All right. Goodbye, everyone.